Hey guys, and welcome back to another video. In this video, we'll be talking about trigonometric equations. Alright, so let's get right into it. Alright, so basically there's mainly only two types of trigonometric equations that you can be asked for. And so the first one is they might ask you to solve a trigonometric equation on an interval, and then the other version is you just solve for all real values. So let's do an example of the first case. So for these ones, you're going to solve on the interval from 0 to 2 pi, right? All right. So the first one, sine x equals 1/2. All right, so let's suppose that we have sine of x is equal to 1/2. So how would you solve this? So first thing you have to check for is to see if you can solve it using exact values, right? And so we know that 1/2 is an exact value. So then now we just have to find the reference angle x. So what's the reference angle for 1/2 for sine? Well, it's pi over 6, right? Because we know that sine of pi over 6, that's equal to 1/2. So our reference angle, which I'll just call x prime, is equal to pi over 6. Okay, so this is our reference angle. So now we have to solve on the interval 0 to 2 pi. So we have to consider the sign, right? So it's positive 1/2. So pi over 6 is a solution. And so then in what other quadrant is sine positive? Well, if you recall from ASTC, sine is positive in the first and second quadrants. So then we just have to find the pi over 6 reference angle in the second quadrant. So if you just do that real quickly, you get 5 pi over 6, right? And these are the only solutions to this equation. So that's the answer. All right. Cool. Let's do another one. So now, leveling up a little bit, we have 2 cosine squared x plus cosine x minus 1 equals 0. All right. So first of all, notice that this is like a quadratic. It's like a quadratic form because you have a cosine squared and then cosine to the first, so you have like a quadratic. So we can try factoring this. And indeed you can. And this factors as 2 cosine x. So let's factor this. So that's how it factors. Okay? And so now we can just set each of these factors equal to 0. So we have that 2 cosine x minus 1 equals 0, or cosine x plus 1 equals 0, right? So for this one, we have to isolate cosine x. So add 1 to both sides and then divide by 2. So you get cosine x is equal to positive 1/2. And then same thing on this side, just subtract 1, so you get cosine x is equal to negative 1. All right? So then for this case, again, we know that 1/2 is an exact value. And then for cosine this time, the reference angle is going to be pi over 3, because you know that cosine of pi over 3 is 1/2. And it's positive 1/2, right? So that means you have to look at the quadrants where cosine is positive, and that's the first and fourth quadrant. So the first quadrant is just pi over 3. So, and then in the fourth quadrant, it's going to be 5 pi over 3. Okay? And then for cosine x equals negative 1, this is one of your quadrantal values. So if you recall, we can remember that cosine of pi is equal to negative 1. So it's also an exact value, just a special type. So then for this one, the only answer in the interval 0 to 2 pi, because remember we're still solving on the interval, is the only solution is x equals pi. And then here it's x is equal to both of these. And so now we have to make sure, we have to check each of our solutions to make sure they satisfy the original problem. And I'll tell you that they do work, but you can double check and just verify that all three of these solutions do work. But yeah, that's our final solution. So it's pi over 3, pi, 5 pi over 3. All right, cool. All right, let's do one more of these solving on an interval. So now suppose we have sine of 2 theta is equal to negative root 2 over 2. All right. So now notice something that's a little bit different right here, right? Because now the argument, the value is 2 theta instead of just theta. So this is going to change our approach a little bit, just because 2 theta, that's a transformation to the sine graph, right? So if we were to like graph sine of 2 theta, this would like take like one period of this would take so one period would be like from there to there. So this would be at 4 pi, right? So one period of sine of 2 theta is 4 pi. But we want to solve in the interval from 0 to 2 pi, right? So essentially, we can just split this up into 0 to 2 pi. So 0 to 2 pi, and then 2 pi to 4 pi. So for the first one, from 0 to 2 pi, we can find all the solutions. And this is just like we do it regularly, right? So again, first we must find the reference angle. So theta prime. And then square root of 2 over 2, so the reference angle must be pi over 4. Okay? And then again, if we were to draw ASTC, this time we want where sine is negative. So that's going to be the third and the fourth quadrants. All right. So in the third quadrant, pi over 4 is 5 pi over 4. And then in the fourth quadrant, it's 7 pi over 4. And notice that this is equal to 2 theta, not theta. This is equal to 2 theta. Okay? And so then we can solve from 2 pi to 4 pi, right? Because then once we get these values, once we divide by 2, we're going to be back into our original interval. So that's why we have to extend our interval for 2 theta, because then once you divide, we're going to go back into our original interval. So this is, we can assure that we get all the solutions. And simply, this one is really simple. All you have to do is just add 2 pi to each of the values that you got before. So 5 pi over 4 plus 2 pi, that is 13 pi over 4. And then same thing, 7 pi over 4 plus 2 pi is 15 pi over 4. And so now when you divide both by 2, we get 5 pi over 8 and 7 pi over 8 for this one. And then here we get 13 pi over 8 and 15 pi over 8. And now notice how all 4 of these angles lie within this range. So now we have all possible values. Because if we had just done this interval to begin with, we would have left out 2 solutions that do fall inside the interval. All right. So then the final solution. Oh, and also don't forget to check your solutions. But again, I'll just tell you that they do work, but you can double check. But make sure that you check your solutions. But our final solutions are 5 pi over 8, 7 pi over 8, 13 pi over 8, and 15 pi over 8. Okay, cool. All right, so now let's move on to the next set of type of equation. So for these ones, it just says solve, right? So now we're not solving on any set interval. Instead, we're just solving for all real solutions, right? So all possible solutions. And so these types of equations, like trigonometric equations, they technically have infinitely solutions, right? Because like it's a wave function, so like it's like a wave. And so if it's like equal to like 2, for example, there's like infinitely many solutions where it intersects. So that's why these have infinitely many equations. So that's why it's going to be impractical to like write out every single solution. But as we will see, the solutions themselves have patterns to them. And so then we can just write it in that form. All right. So to show you what I mean, let's just solve this example right here. So first thing we have to do is you have to isolate the trigonometric function. So in this case, cosine. And so you get cosine theta. So cosine squared theta is equal to 1/2. And then take plus minus square root. So you get cosine theta is equal to plus minus 1 over 2. This is supposed to be 1/2. So you get 1 over root 2. And then rationalizing this, you get root 2 over 2. So then you can hopefully recognize this is an exact value, and the reference angle theta is pi over 4. So I'm going to split this up into 2 cases, right? So case 1 is cosine theta is equal to square root of 2 over 2, and then case 2, cosine theta is equal to negative square root of 2 over 2. Okay, so for this one, we want where cosine is positive. So that's in these two quadrants, 1 and 4. So we have pi over 4 and 7 pi over 4, right? And then for these two, or for this case, we have where cosine is negative. So that's in these two, quadrant 2 and quadrant 3. So we have 3 pi over 4 and 5 pi over 4. All right. But we want all possible solutions. So notice that if you take pi over 4 and you add pi to this, right? So pi over 4 plus pi, you get 5 pi over 4, which we already have. So this means that pi over 4 is a repeat solution because we can realize that all pi over 4 plus multiples of pi are all going to be solutions to this equation. So therefore, and then same thing with 7 pi over 4, right? 3 pi over 4 plus pi gives us 7 pi over 4. So this is also just a repeat solution. So in the end, we get that theta is going to equal pi over 4 plus pi n, and then 3 pi over 4 plus pi n, where n is an integer. All right, so a couple things, right? So first of all, n is an integer, it's just like denoted like this, right? So this is basically saying n is an element of the integers, okay? You don't have to write it like this. Obviously, you could just write out where n is an integer, but just for neatness and like less writing, I'm just going to write it like this, right? It's much more convenient. And then secondly, let's like investigate why this works. So if we were to draw in the unit circle, right? So pi over 4 is like right that angle right there, right? So we know that cosine of this angle, so this is pi over 4. So we know that cosine on the unit circle, this would be root 2 over 2 at this point. Okay? So then if we add pi to this, so that's like going like that. So now we get negative root 2 over 2, right? But remember, we want cosine squared, so then negative and positive, it doesn't matter. And then same thing for like the 3 pi over 4, it's like right here, right? And then so this is like, so this is like 3 pi over 4. This is a root 2, negative root 2 over 2, root 2 over 2. But then if you add pi to this again, so if you go like this, then this angle is root 2 over 2, or this coordinate is root 2 over 2, negative root 2 over 2. So basically, like rotating, like multiples of pi over 4 are solutions of this, and then multiples of 3 pi over 4 are also solutions of this. Okay, cool. All right, now let's do another example. So sine x plus cosecant x equals negative 2. All right, well, let's see. Let's get everything into sine first, right? So we can rewrite cosecant as 1 over sine. And then now let's multiply both sides of this by sine. So then we get sine squared plus 1 is equal to negative 2 sine. Okay? So now moving this over, we can realize that this is actually just a quadratic in terms of sine. Right? And so then we can factor this as, so if you notice like the perfect square trinomial, you can factor it that way. And so you get sine x plus 1 squared is equal to 0. And so then that means that sine x is equal to negative 1. Or here, I'll say that means sine x plus 1 is equal to 0, which means that sine x is equal to negative 1. And this is also a quadrantal value, right? So if x is equal to 3 pi over 2, then sine will be -1. But remember, we're not solving on an interval. We're solving for all possible values. So we must add multiples of 2 pi. Okay? And the reason we add 2 pi this time is because only 3 pi over 2 is a solution to this. So like in the coordinate plane, 3 pi over 2 is right here. So then if we add 2 pi, that's one full revolution. So then we get back to this point. And then n is like an integer. So you can even add like negative multiples. And then like keep getting back to this same angle. All right. Nice. So this is the solution. Coolio. All right, let's do one more of these, and then we'll move on to a different type of problem. All right, cosine 2 theta is equal to 1/2. So again, for this one, notice that we have 2 theta, so that means that we must extend our interval. But we only had to extend our interval because we're solving because we're solving on an interval. But now that we have no interval, we can actually just solve on like the regular 0 to 2 pi interval and then add multiples of 2 pi. Okay, cool. So first of all, let's find the reference angle. So the reference angle for this is pi over 3. Okay, so then we want where cosine is positive 1/2. So again, looking at ASTC, we know that cosine is positive in the first and the fourth quadrants. So in the first quadrant, pi over 3 is just itself, and in the fourth quadrant, it becomes 5 pi over 3. All right, and so then now we can just divide by 2, so we get theta is equal to pi over 6 and 5 pi over 6. So then now we can just add 2 pi to each of these. Oh, very important note actually, that even I just forgot, is that you should have to add your 2 pi, like you have to add your multiples of 2i before you divide by 2. So you have pi over 3 and then 5 pi over 3 plus 2 pi n. So you have to add that before you divide by 2. And then you divide by 2 afterwards, so then you get pi, or theta is equal to pi over 6 plus pi n now, and then 5 pi over 6 plus pi n. Okay? Because if you add 2 pi n afterwards, that's going to lead to the wrong angles. Or rather, it's not going to lead to wrong angles, but rather you're going to miss out on angles, because then you're only going to add like even multiples of n, right? But yeah, these are the two solutions. And then don't forget to include where n is an integer. All right? Okay, so now let's move on to a like different type of problem, namely inequalities. So we're going to solve on the interval 0 to 2 pi. So we're back to intervals. But the only difference is that now we're dealing with an inequality. So we have 4 cosine x minus 1. When is it less than or equal to -3? So again, the first step is, like always, is just to isolate the cosine x. So we get a -1/2. And then we can make like a rough sketch of this. So let's say this is 1, this is -1, and then we have like pi over 2, pi, or sorry, pi, 2 pi, and then like intermediate values. So if we just sketch like the parent function for cosine, we should get something like that. Okay? And you want to know where is it less than or equal to -1/2. So -1/2 is like this line right here. And so it's less than or equal to. So that means you're including where it intersects the line and then everything less than. So it's like this portion of the curve right here. So essentially, we just have to see where is cosine x equal to -1/2. So this is just like the other problems that we did. So we're solving this equation on this interval. And so you will get 2 pi over 3 and 4 pi over 3. but we also want everything in between, right? So it's the interval, 2 pi over 3 to 5 pi over 3 included. All right. So that's kind of like a glimpse at trigonometric inequalities. So it's pretty much the same idea, right? You're solving still, but like now you just have like an interval of solutions since it's an inequality. All right. But yeah, that pretty much wraps up this lesson on trigonometric equations. If you enjoyed the video and you found it helpful, please make sure to leave a like and don't forget to subscribe. I'll see you guys in the next video.